Hello everyone, my name's Keith Laker. I'm part of the product management team for Autonomous Database. Welcome to Oracle Database World AI Edition. I'm going to talk to you today about hands-free operation for Autonomous Database, essentially how we can make your life easier. I'm going to talk to you about how we control resources, hands-free operation of resources, compute resources, storage resources in a completely elastic way. I'm going to talk to you about the very important topic of patching and upgrades, which I'm sure is familiar to a lot of database users, and how we've automated that. Talk to you also about some of the monitoring that, as part of the hands-free processing that we do behind the scenes, we've surfaced some of that for you to use, to integrate with, to set up your own notifications and alarms and events. And then finally, we'll look at the automation that we've added to disaster recovery. So let's start off with elastic resources and pay-per-use billing. This is probably one of the big reasons for coming up to the cloud, primarily to get things like pay-per-use billing, but also the flexibility that as your workload grows or shrinks, that your resources can follow that expansion or shrinkage. So with Autonomous Database, we use this concept of eCPUs for compute, and obviously storage in terms of gigabytes. And those are completely separate. So the compute and the storage can be sized independently. They're not set up in fixed shapes or sizes, or t-shirt sizing, as some people call it. You can at a very granular level, determine the amount of compute and storage space that you want to use. So this makes it very easy for you to add additional resources. And going through that adding of additional resources, there's no downtime. So one of the things that we do is you select the amount of compute resources, we turn on something called auto scaling. And this instantaneously adjusts the amount of compute and IO available within your instance based on the actual workload that's running at that particular point in time. So as the additional resources, as the auto scaling kicks in and increases the resources, you are only charged for the resources that you use. And obviously, as the workload requirements shrink, then the compute resources are also shrunk at the same time. And through either manual shutdown or through automated scheduled shutdown, you can turn the system off, and at which point we stop charging you for compute resources. So a lot of ways to get a very, very cost-efficient database service. So what does this look like? Sizing a workload to run on Autonomous Database is a little different to sizing for typical on-premise environments where it's running in your data center, or with other cloud databases. You're typically looking to grab a workload and look at the total amount of resources it needs, and then you size for that. With Autonomous Database, you're really looking for what is the steady state operation. How much resources do I need to maintain that steady state? And then by enabling auto scaling, which is on by default, by the way, the system will automatically flex upwards up to 3 times the number of CPUs that you put as your steady state or baseline. And as the workload increases, the resources automatically increase. And as the workload requirements come down, the amount of compute allocated comes down as well. And you're only paying for the compute that you use on a per second basis. And this all happens with no downtime. So the system's up, continual available, continuing to run your workload as resources are added or removed. You can apply that same concept to a fleet of databases with what we call the family plan for Autonomous Database or elastic pools. So at this point, we can take a fleet of databases and bring them into a common pool where they can have access to a base set and scalable set of compute resources. So you're charged for the pool, but you may have hundreds of databases sitting into that pool. So it becomes much more a cost-effective way to pay for the pool. And then as the workload changes on individual databases, they can make use of the resources within that pool, given that for large collections of databases, some databases might have high resource requirements, some might have low resource requirements, some might be on, some might be off, and so on. So this gives you a much more cost-effective way to run and automatically manage the resources for a large fleet of databases. One area that generates a lot of interest is patching and upgrades, particularly if you're having to do this all yourself. The nice thing about coming to autonomous database in the cloud is this all gets automated for you. So there's no actions that you need to do. The patches are applied on a given schedule, and I'll show you that in a minute. There's no downtime as we're applying all these patches. As part of the patching process, we're automatically adding any security fixes. So your system, your autonomous database, is always running with the very latest security fixes from Oracle. And of course, we're patching the whole stack. So we're patching the database software as well as the hardware, the operating system. We're taking care of all of that environment for you. And because we're doing this on a regular cycle in sort of very, very small batches, we're able to also bring some new features to you as part of that cycle as well. So you get seamless improvements to the service with new features every time we run through a patching cycle as well. And in the last 12 months, we delivered around about 170 new features. Now, because we're doing this on a regular basis and the patches themselves are quite small because we're doing it so regularly, the level of quality that we're able to bring to the patching cycle is significantly higher. So there are a lot fewer service requests from these environments running autonomous database where we're doing this regular patching. Customers are seeing lots and lots of benefits from being able to take advantage of the fact that all of the patching, security fixes, and everything are completely managed for them. As I said, the patching process is run on a scheduled basis. You can see the schedule on the console itself. There's zero downtime here. So even though we're patching for particular windows or during particular windows, there's no downtime for your instance. You can get event notifications as to when we're starting a maintenance cycle and when the maintenance cycle ends. If you need to have that to orchestrate particular workflows that are running on your database and you want to avoid those running within the maintenance time. If you want to dive into the history of the patching process, what we've done, what we've delivered, when it's going to be planned, how long it takes to run, etc., all of that information's on the console, and correspondingly, you can access it directly from within your autonomous databases through SQL views as well. Now, for mission-critical systems, mission-critical environments, we know customers like to sort of get a heads up on any patches that are coming down the line. So as part of the process for either building a new autonomous database or cloning an existing one, we've given you the ability as part of that build process to tell us which patching cycle you'd like to be in. So for mission critical database, it's quite often useful to set up an early maintenance cycle, and at which point you get 1 week, 7 days prior access to the patches that are coming in the next regular patching cycle. So you can do that for pre-testing and validation for these mission critical environments to make sure that your existing workload is going to function as expected when we apply the next regular patch. How you test that? So we've given you the ability to obviously consume the patches early, and we've also automated the ability to capture the workload on your production database, for example, and then replay that on your clone. So this is part of the real application testing. It's a highly automated way for you to harvest the workload, move that to your early patching environment, say a clone, and then simply replay that entire workload so you can have the confidence to know that when the regular patching cycle kicks in, that your workload is going to continue to run as expected. For monitoring your database, typically here a number of personas come into play, depending on sort of the scope that you want to do. So for detailed real-time operational monitoring, there's a performance hub built into the OCI console, as well as available from within Autonomous Database on Database Actions, which gives you very granular access to the different operations that are currently running inside your Autonomous Database. If you want to sort of take a step up and have a longer view as to the workloads, how resources are being used on your database or fleet of database, there's service metrics, pre-built metrics, charts, etc., that you can use to get a high-level view as to what's happening with your Autonomous Database. And then from a fleet perspective, you can get another sort of more aggregated view of what is happening across your fleet, as well as some planning capabilities to understand how your resources might need to grow or could be shrunk going forward over time. So different consoles to meet the different needs of different personas within your organization. And as part of that automation that we do in the back end to keep all these autonomous databases running in our cloud data centers, we've taken some of the work that we do and work that we leverage with our cloud ops team and pushed those out onto the console for you to use. So there's a whole series within the monitoring service of pre-built charts to give you some insight into certain metrics, things like CPU utilization, storage utilization, and so on. And you can dive into those and drill in, as you can see on the menu here. You can view the query in a deeper way using Metrics Explorer, where you can write your own queries to understand, for example, how CPU utilization is changing over time. Or more importantly, you can create an alarm. So once CPU utilization hits a specific percentage, you can have the system automatically send you a message. And that messaging can be through all sorts of different methods. It can be an email, it can be a JSON file document that goes into, say, something like a Grafana dashboard. It could be a message to Teams or a Slack channel. Essentially, there's a lot of capabilities here because Autonomous Database is plugged into the cloud notification service. So it's not a black box. The cloud system can understand how the database is operating, and therefore the operations can look and use all of the capabilities of the OCI cloud, particularly in this case, the events, rules, and actions service. And we've surfaced a whole series of event types for Autonomous Database that you can sign up for to understand how different operations happening on your database. Either the database is stopped, it's starting, you're switching over, and we'll come to that next. For a disaster recovery situation, database is being terminated, and so on. So all sorts of events that you can subscribe to, and then have those events send out messages to whichever channel you want. So I talked about events happening for standby, failover, etc. To help you manage disaster recovery situations, we have two capabilities: Autonomous Data Guard for mission critical environments. So if you're used to our maximum availability architecture, Autonomous Data Guard brings you a gold standard environment, and this delivers the fastest recovery time for your database. If you want to be able to recover in the same way, i.e. through the high level of automation that Autonomous Data Guard provides, but you don't necessarily need to be up and running instantaneously, then you can opt to use backup-based disaster recovery. So how does this sort of generally work? There's sort of two aspects to this. Either we keep the standby database or within the same data center. So we create what's called a local version, and this protects against outages within the machine that you're running in or the availability domain that's running. And we can automatically fail over to the standby database very, very quickly and easily. There's no reconnection. The URLs for all the tools that are associated with Autonomous Database, things like database actions, Apex applications, OML, etc. No need to change the network configuration. Everything continues to work seamlessly. So we simply switch from the from the primary running in one availability domain to the standby running in a separate availability domain. And although that can happen automatically, you can, through one click, enable that switchover either for testing or to actually make the switch from primary to standby. The other option is that you may want to have the standby database in a completely different region. Again, it's one click to enable it, and you simply point or tell us which region you'd like the standby set up in. Now, in this case, because as you'll have probably noticed when you look at your URLs, when you're accessing your Autonomous database, the actual region that you're running in is part of that URL. So there's a slight difference here when we decide to enable a cross-region Autonomous Data Guard, in that the tools themselves will have different URLs, and the wallet will be different to access the standby as well. Now, a lot of the tools that we have, the services that we have from Oracle, are able to manage automatically, transparently, this switching over from one environment to another through either the wallet or the connection strings that are provided. And this gives you slightly more control over the environment, but there's no automatic failover. So the manual failover, which you can use for testing to make sure that everything is working, that also has to be done to move from the primary, should it become unavailable, to the remote standby. Now, by moving to an Autonomous Data Guard environment, you get a much, much higher SLA. The SLA with the standard database is 99.95% availability, which is extremely high for cloud databases. By adding Autonomous Data Guard, we go up to 4 nines, so we get 99.995%, and that covers not only the cloud infrastructure that you're running on, but also the complete software stack as well, all the maintenance and patching. That's everything that's covered by that SLA. And now, uniquely, we do publish the level of availability that we're able to sustain each month within each of our regional data centers for the autonomous databases that we're running. There's a page that's available on oracle.com. You can see the link here that gives you insight into the availability metrics for the last 3 months. For customers, use cases where you don't need that immediate stand-up of the standby database, you can opt for either a local or a cross-region failover using a backup. So we'll take the backup, we'll take the redo as part of this. This is all automated. It's all very simply enabled through one click. You get the options to either use Autonomous Data Guard or switch to local backup. So it's very easy to set up and configure, a couple of mouse clicks, and then we'll take care of everything else for you. The nice thing about having Autonomous Data Guard, where we have these databases that are set up as the standby, is that you can actually use that standby database to do other operations. So you can take some of the workload that you might push to the primary, particularly, say, queries and reports that you might want to run on the primary. You can take those and offload them to region 2. So we can convert that standby database to a snapshot standby for 48 hours and then run a query workload on it and then reconnect it and convert it back to being the failover peer. So that's a very cost-effective way to use these cross-region standby databases. So closing takeaways. We talked a lot about automation here. The idea, our objective with doing all of this automation, there's two key things we want to do for you. One is to reduce your risk, and the other aspect is to lower your cost. So from a risk perspective, the ability to know that you always have the very latest patches, you always have the very latest security patches, and those patches are applied with zero downtime, is a huge win to come up to the cloud and to bring a workload to Autonomous Database. The ability to efficiently manage your costs through elastic resources, pay-per-use billing, whether that's for one instance using auto scaling or whether that's for a fleet of databases using elastic pools. Those capabilities are there and can give you proven cost savings over time. We do an awful lot of monitoring behind the scenes. That's why the database is called Autonomous Database. And as part of that automation that we use, we've resurfaced a lot of that capability that we built into the database as a built-in library of metrics and alarms that you can access. And you can leverage those along with the built-in metrics that we've got around performance and monitoring to automate your own hands-free management monitoring of your autonomous database or fleet of autonomous databases. There's also the high availability aspects that we've automated as well to make it as simple as possible to enable and test and also leverage that standby to give you a cost-effective way to have a high availability environment assigned to your autonomous databases to give you full protection for your workloads. There it is. Complete hands-free operation for your autonomous database. Thank you very much for joining this session, and I hope you enjoy the rest of Oracle Database World AI Edition.